couple of interest lines on us, and I'll talk about our approach to security. So we've been going for about 3 years now, it's just under 3 years actually. We've managed to build 150 projects now into public cloud, consisting of in the region of 250 different workloads that we've now deployed, some of which we've migrated from on-premise data centers, and some of which we've built net new in the cloud. And we've managed to do all of that with 25 engineers, and actually we've only had that many engineers for the past few months. We've pretty much doubled our team size every 6 months since we started. So what I'm trying to tell you there is that even in enterprises like KPMG, adopting cloud and adopting DevOps and the kind of things that we do is not only possible, but it's actually encouraged and very successful in these organizations. So what kind of areas do we cover? As you might imagine, KPMG has a lot of clients in banking and public sector. We've done significant workloads for large multinational banks and a lot of the largest banks you'll be familiar with in the UK. We've done some significant workloads in the government sector for civil service, and we've done some very large UK retailers, and obviously we've got our internal clients in our tax and audit businesses. Now, there's something that's quite similar about all of these different areas in that they're all, for a start, very sensitive about security. They really want to understand how you've secured your environments and your approach to security. And they're also quite reticent to leverage cloud services in lots of cases, and they use security as an excuse for that sometimes. So us trying to educate both our clients internally and externally on the advantages of cloud and why it is actually, I believe, far more secure than our on-premise data centers is quite a challenge for us. So what was our approach? So obviously we're trying to do this at scale. As you saw, there's 250 plus workloads in the cloud. So consistency is really important for us. We want to have a consistent approach to all of our environments. So we like to treat particularly in our infrastructure as a service usage, we're trying to go for a cattle rather than pets approach. Now, I can't stand here and say, hand on heart, we have no pets in our environment. We do have this legacy stuff that we've got to look after occasionally, and we can't treat like that. But I think if you can go towards a consistent model where all of your instances are deployed in a consistent manner, are secured in a consistent manner, and configuration managed in a consistent manner, then what it means is when you have to roll out updates and changes, it's far easier, you can do it with a far smaller team, you get great operational benefits from doing that. So I've listed obfuscation here, and what I'm trying to say there is, whilst we configure secure instances in our cloud environments, there's actually very few use cases where you need to expose them directly to the public internet. What I like to do as much as possible is to place as much of AWS's infrastructure in harm's way as I can, so that our instances are by default protected. Even if that only consists of an elastic load balancer in your equivalent of a DMZ or a public subnet, I think that's far better than actually exposing your own instances to the internet directly. And I've got a real-world example I'll talk about in a couple of slides' time. Access controls. So I know in our on-premise data centers we have some Active Directory users that have certain permissions and certain servers to go and do administrative jobs. I also know that those tend to propagate quite quickly, and before you know it, you have a huge JMO, joiners, movers, leavers process to try and understand who has access to what, and should they have access to that, and should we remove that access. It's caused all kinds of problems. So our default position is nobody has access to 25 instances. RDP is switched off at all given points in time. SSH also switched off. And frankly, actually, any other protocols that are not needed by that service are switched off at the security group's layer. So we're protecting from unauthorized access, and also, if someone did manage to break those security controls, we're preventing horizontal access within the environment. So if people do get onto an instance, they can't access others within our environment. We do allow connectivity to those servers, but it's on a very strict process, and it's only under emergency conditions. So it's not that we prevent it completely, but I think it's really important that we don't just have that access available at any given point in time. So segregation, I think one of my favorite terms around this is limit your blast radius. So if there is a security incident in your environment, what you don't want that to do is impact all of your services. So we separate at an AWS account level between all of our projects we serve to different clients and the environments within those projects. So if we did a project for a large banking client, they would get a series of AWS accounts through dev, test, pre-prod and prod as a minimum. Oftentimes we have more than that depending on the kind of testing we want to do. What that means is that if there's an issue or an incident in one of those AWS accounts, there's been a misconfiguration, for example, it would only affect that. So we can say with a great deal of certainty to our clients that should there be an incident affecting one of our other clients, it would not impact them. And then process. Process is probably the most important piece here, actually. I think as Dave mentioned, people probably provide the biggest risk to our environments. Out of anything, you can automate a lot of this stuff. So we've adopted the software development lifecycle process around our deployments to cloud. So the way we look after infrastructure is very much infrastructure as code. We commit our CloudFormation templates in source control, we do peer review, and we use that as a process to try and make sure that we've implemented the DevSecOps piece and truly have, double-checked our work that we are deploying securely. So what does that result in? We've now defined a security pattern. And now what we've managed to move away from with our on-premise environments where essentially our security teams would have to be in line in every single project and every single deployment and really taking great care on every change that's made in each environment individually because those environments weren't consistent and were quite different to each other. We've now got a single pattern that our security teams can iterate, improve that pattern such that every environment that we have across AWS can be improved simultaneously. And if there's an incident, then we know we've got a consistent approach to all of our different environments that we can implement in order to further secure them. So I've got a real-world example. So a few weeks, maybe a couple of months ago, there was WannaCry, was a thing that happened. We've obviously got some on-premise infrastructure as well as our cloud infrastructure. So what I'd like to do is compare the two and just show you how much easier it was for us to look after our cloud infrastructure than it was our on-premise. So in the cloud, we have no of our instances internet-facing. On-premise, we actually do have some, whilst they're behind firewalls, they are, largely speaking, some are in our DMZ, and they were internet-facing. So we had ourselves an issue there. In terms of patching, so we leveraged RDS almost across the board. I think we've got a couple of instances where we've had to build SQL Server instances ourselves, but the vast majority of cases we leverage RDS. So when we get asked, have you patched your database environment, we can say, well, yeah, we use RDS, it's automatically patched from our patching window, we can see from the logs that this happened. In the case of WannaCry, actually Microsoft issued a patch for these servers even a couple of months before the incident happened, so we were in a really good spot there. I know in our on-premise environments, that wasn't necessarily the case. They had limited high availability, so they were patching database servers in line. This could result in downtime, so there's a lot of business pushback saying, can we not delay this patching because I don't want it to affect my clients, I don't want it to affect my service. RDS gives you all that under the hood, really nice and easy. And the other thing I'd say is we leverage a lot of platform as a service offerings from AWS, so S3 is a great example. S3 clearly wasn't impacted by WannaCry as an issue, so we could pretty safely say that almost all of the data we were storing was very secure as a result of that incident. SMB was disabled in all our security groups. That's both vertically through the environment and horizontally through the environment. So what we could say with a great deal of certainty is, and obviously, sorry, with the AWS account segregation, we could say with a great deal of certainty that even if one of our instances was compromised, it'd be incredibly difficult for that particular piece of malware to spread through our environments. That wasn't necessarily the case in some of our on-premise infrastructures. We had far flatter network designs. We didn't have per-node firewalls across the piece, so the chances of that particular piece of malware spreading, if it did infect one of our environments, we're glad to say it didn't, but if it had have done, it would have been a much more serious incident for us. So I mentioned account segregation and limited blast radius, and as I said, on-premise, one instance can expose the entire estate. Our approach to patching in the cloud, we've got a gold AMI image. We simply patch that, roll it out amongst our auto-scaling groups. We could do that in a zero downtime manner. We're just ripping instances out, replacing them with brand new ones. And this is just a far easier process than what we had on premise, where we had several hundred physical and virtual instances that we had to patch in line. We had downtime on a number of our services, And I mean, obviously we had to do that out of hours, but what that meant for some of our engineers was some very late nights and a lot of stress in trying to get our environments up to scratch. So according to the clock here, I think I'm pretty much out of time. But one shameless plug, I'm not sure many people have expected KPMG to be in a kind of DevOps and cloud kind of space. It's not that uncool a place to work, despite all the marble and the pinstripe suits that some of our consultants wear. If anyone's interested in working with us, I think it's a pretty cool place to work, so ping me on LinkedIn or come and see me afterwards. Thank you very much.